Hey everybody, this is video 8. This is our last section of chapter 2. We're going to be graphing linear and absolute value inequalities. Okay, so we've graphed linear and absolute value equations. Now we're graphing inequalities. Okay, when we're graphing inequalities and we're going to be on a coordinate plane, and our line, if it is going to be solid, okay, is going to have one of these two inequality symbols in our inequality. If we have one of these two symbols, our line is going to be dashed. What that means is that if I have one of these guys, it means the points on the line are all solutions to the inequality. Here, the points on the line are not solutions. Alright, so before we jump into the inequality business, let's just remember how to graph something like this. So we'd have our coordinate plane. And we'd start at -4 because that's our y-intercept. And we put a dot. And then my slope is 3, or 3 over 1. So therefore I'd go up 3, 1, 2, 3, and to the right 1. So we'll assume this is 1 here. And then I have my line. Okay? Alright, so what if we have that same exact problem, except now it has an inequality symbol? Okay, well, I'm going to start off the exact same way. So I'm going to start with my coordinate plane. I'm going to start at -4. And I'm going to go up 3, 1, 2, 3, and right 1. Okay, so essentially I have not done anything different this time yet. Okay, this is a greater than symbol, so it's one of these guys right here. So therefore it's going to be a dashed line. So I'm going to draw on my dashed line. If you forget to make it dashed and you accidentally make it solid, just write the word dash next to it. That's totally fine. Okay, so 2 extra things you need to remember. First is dashed versus solid. Is your line going to be dashed or solid? The second thing you have to remember is shading. Okay, when you shade, you're going to pick a point that's not on the line. So if 0, 0 doesn't fall on your line, that's the easiest one to pick. So 0, 0 is right here. So again, if 0, 0 is not on the line, you can pick that one. And you're going to plug x and y for 0 into your inequality over here. So y becomes a 0, x becomes a 0, and you're going to simplify both sides. Okay, well this side can't be simplified at all, so we just keep it 0. 3 times 0 is 0, minus 4 gives me -4. Okay, and here's where you ask yourself, is that a true or a false statement? So is 0 greater than -4? Yes it is, that is true. Okay, so if it is true, you're going to shade on the same side where your point was. So 0, 0 is on this side of the line. It's true, meaning it is a solution, so I'm going to shade that side of my line. Okay, so my solutions then are everything in the shading. Okay, in this case our solutions are not on the line because it's dashed. All right, next one. Okay, we're going to graph this inequality here. We have y equals 2x minus 6, which is less than or equal to 12. Okay, so this guy is in standard form. Okay, when we have standard form, we're going to find our x-intercept and our y-intercept. This is the easiest way to do this. Okay, so I'm going to say 2x equals 12. So x is 6, because remember if we cover up the y's, we can solve that for x. So our x-intercept is 6, 0. Okay, I'm going to do the same thing for my y, so -6y equals 12. So y is -2 or 0, -2. This stuff right here was back in video 2. So if we don't remember how to graph in standard form, this would be something where you could go back and look at video 2 of how we did that. Or look at your video 2 notes, and we did something very similar to this when this was an equal sign. Okay, so at 0, -2, I've got my first dot. And at 1, 2, 3, 4, 5, 6, 0, I've got my other dot. Okay, so there's my 2 dots. Now I just need to figure out what I'm connecting them with. Okay, well, since this has an equal sign underneath it, I have a solid line this time. All right, 0, 0 is not on the line, so I'm going to use that one this time again. So I'm going to plug 0 in for x. So 2 times 0 minus 6 times 0 is less than or equal to 12. Well, all this left side here, okay, is going to become a 0. So I have 0 is less than or equal to 12. That is again true. So I'm going to shade where 0, 0 is again. So if this would have ended up to be false, I would have shaded the other side of the line. Okay, so this time my solutions are in the shaded and on the line because it's a solid line this time. So the shading tells us where my solutions are. So I could say like 0, 0 is a solution. I could say like 2, 0 is a solution. Okay, if I pick any point down here, it's not solutions, meaning if I plug it in this inequality, it wouldn't be true. Okay, here we're going to graph an absolute value one. Okay, this is going to work the same way. So remember what we did when this was an equal sign and we had absolute value. Okay, we started with a table of values. Okay, well, what is going to make this 0 on the inside? -3. So that's what I'm going to plug in there. And I'm going to get 4 other values, 2 on either side. Okay, so if I plug in -5, I get -2 here, which is 2. The absolute value of that is 2. Minus 2 gives me 0. If I plug in -4, I get -4 plus 3, which is -1. The absolute value of that is 1. Minus 2 gives me -1. If I plug in -3, that's going to be 0. Minus 2 gives me -2. If I plug in -2, I get 1. Absolute value is 1. Minus 2 gives me -1. And if I were to plug in -1, I'd get 0. Plot my points. 2, 3, 4. -5, 0. -4, -1. -3, -2. -2, -1, and 1, -1, 0. Okay, so we have our V shape because this was supposed to be a V shape because it's absolute value. All right, this one's going to be a solid line again because there's the equal to sign there. And now my shading gets a little bit easier with the V's or with the absolute values. This says y is greater than. Okay, well, if it's greater than, it's going to be above the vertex. If it's less than, it's going to be below the vertex. Okay, so greater than would be above the vertex, so inside the V. So if it's greater than, it would be above the V. If it's less than, it'd be below the V. All right, and our last one. So a recreation center offers 2 different types of music classes, or classes, 30 and 60-minute ones. The director allots 20 hours a week for classes. So first of all, before I even read the rest of this, I see this is minutes, this is hours. So I'm probably going to have to convert this to minutes. Write and graph an inequality to represent the number of 30 and 60-minute classes that can be held. Okay, so 20 hours equal to how many minutes? So I would multiply that by 60, and if I get that, I get 1,200. Excuse me. Minutes. So I'm going to use this number now instead of this one. Okay, well, my 30-minute classes, okay, plus my 60-minute classes is going to equal 1,200 minutes. Okay, so I could say 30x plus 60y equals that, but it doesn't always equal exactly 1200. It just has to be less than or equal to the 1200 because they only have the 1200 allotted. So this cannot be greater than 1200 minutes. So basically what this is saying is we're going to take 30 minutes times the number of 30-minute classes, 60 minutes times the number of 60-minute classes has to be less than or equal to 1200 minutes. Okay, so when I go to graph this then, okay, so there's my inequality. When I graph it, I'm going to find my x and y intercept. So 30 is less than 30x equals 1200, and 60x or y equals 1200. So y would be 20, and x is going to be 40. Or in other words, 0, 20 and 40, 0. I'm just going to go up by tens here. And at 40, 0 is my x. And at 20, 0, 20 is my y. Okay, this is going to be a solid line because it can be equal to any of those. And technically I don't need this because no negative answers are going to make sense in this. Okay, and then we want to graph. Okay, so we're gonna, shade. It's a solid line because it's less than or equal to. If I plug in 0, 0, if I plug 0 and 0 in there, I get 0 is less than or equal to 1200. Well, that's true, so I'm gonna shade underneath the V. And the only reason I'm shading just the triangle is because negative numbers will not make sense in this case. So really, I don't need any of these three quadrants because they're not gonna make any sense in this case. All right, and that is graphing linear and absolute value inequalities. We will see you next time.